Greetings, I'm Squared here. We're going to factor some trinomials today. Before we do that, we're going to do some prep work. So we're just going to get our mind wrapped around having a number and asking what is the product, what are the factors of that number that add up to another number. So we're going to say find two numbers whose product is one number and whose sum, so we're talking about the same two numbers, is a different number. So this is our product column, this is our sum column, and this is our prep work for factoring. So this one says, what are two factors? You would ask yourself, what are two factors of 42 that add up to negative 17? Or find two numbers whose product is 42 and adds up to negative 17. So to do that, I like to write all the factors down, unless I see it right away. Some people see it right away. I like to write them down. I notice that the product is positive, but the sum is negative. That only happens if both factors are negative, because a negative times a negative is a positive, and a negative plus a negative, which is the sum, would be negative. So you see they're all listed here. 1, 2, 3, 4, and 5 don't work. 6, and then I'm bringing back a 7. So I know I'm done when I get two numbers like this, when I start going back up the other side. I like to write them in order that way so I can see when I'm done. And you'll notice that these are the ones that work, because negative 3 plus negative 14 get me my negative 17. So those are the ones I would use. Even though there's more factors, I'm only looking for the pair that adds up to that number. So when I look at negative 81 and I'm getting a positive number, that means I'm going to have a positive and a negative. Well, which one would be positive? Well, if that could be either one, right? But if this one was negative, I would get a positive answer. If the 81 was negative when I added them, I'm talking about adding them. If this one was negative, I would get a negative answer. Since my 24 is positive, I know that my smaller number is going to be negative. So does 2 go into 81? If you're not sure, you're just going to have to get out your calculator and divide it by 2 and then 3 and then see what it equals. But hopefully you have some sense of the number, the divisibility rules. I know that 2 doesn't because it's not even. That's the rule for 2. I know 3 does because 8 plus 1 is 9 and 3 goes into 9. So I know that works for 3 and 9 when you add up the sum and see if it's divisible by 3 or 9. So I know that goes in 27 times, and I know 9 goes in 9 times to 81. And here they are, 27, right, plus a negative 3 gets me my 24. So the two factors of negative 81 that add up to 24 are 27 and negative 3. How about 100? Well, again, I have a negative, but this time this guy's negative. So now I know that my bigger factor will be negative. Well, that gets me a negative 99. 2 goes into 150 times, but that would give me a negative 48. 3 doesn't go into 100, but 4 does. It goes in 25 times. Getting closer, right? That would be a 21, negative 21. 5 goes into there 20 times, and there's where my negative 15 comes in when I add those two factors. So 5 plus a negative 20 gets me my negative 15. Okay, 30. Again, I have a negative, and I need to add to get a positive. So I'm going to look at my smaller factor being negative. So that gets me a 29. If I check out the factor of 2, there's my 15. There it is, right? And I don't have to write the rest of them. If I see it right here, I don't need to write 3 times 10 and 5 times 6. I can just use those. Whoops, plus. That is how I get my 13. So that's kind of the prep work. When you factor trinomials, you will do that every time. Whether you do it in your head or write it out, you're going to be doing that process. Two factors of this that add up to that every single time you do it. So let's recap FOIL, because I want to make sure you remember the box method from FOIL, right? We get x squared if we did it like that. When we used our box method, we put the two binomials on the sides, and then we multiplied. So column times row, so that times that equals this, and then this row and this column get me my negative 5x, and then these two get me my negative 15. If you did it out with FOIL, you would have gotten this, but you would have combined those two. So the important thing to notice is that these two multiply to get that first quadratic term, these two multiply to get that constant term, and then the inners and the outers, or these two parts of the box, were the ones we combined to get that middle part. So we would have gotten an x squared minus 2x minus 15. So we were doing this now in factoring, we're taking a trinomial, we're moving it back, and we're saying, hey, here's a trinomial. Can you find two binomials that would multiply together to get that trinomial? So I'm going to teach you how to use that box method backwards. But it's going to take this little thing we did up here. So the first step in factoring is always trying to find the greatest common factor. There's not always one, but you want to make sure you try it, because if there is, factoring it out makes this a whole lot easier. I want you to notice that there's these, it says what is a quadratic trinomial? This is a quadratic trinomial. We talked about degrees and stuff, but I want to make sure you know that the kind that you're going to see in this is always going to look like that. So it's going to have the same variable. One's going to be squared. That quadratic, that first leading term is going to be squared. The number in front of the x squared we're going to call a. The number in front of the linear term, or the x, this linear term is going to be b, and then that's going to be c, the constant. You always want to ask yourself, whenever you're factoring trinomials, what factors of AC add up to b? So we were that prep work we just did, two factors that add up to a certain number, that's what we're asking. So check for a greatest common factor. This always should be your first step. This doesn't have a number, that doesn't have an x, there's no greatest common factor. Okay, so what factors of AC? So normally we have an AC out here, but you'll notice that A is 1. So it's when they're easy like that, when A is 1, it's kind of like saying what factors of C add up to B. But I'm going to just put that little A out there so you can kind of get used to that for the next level up. But C is 16, B is 8. So we're saying what factors of 16 add up to 8. So some people can just see it. Other people have to write it out. 1 times 16, 2 times 8, 4 times 4. Okay, there it is. That sum is 8. So once we do that, we're going to fill it in backwards in our little box. That 4 and 4, really to get an 8x, it would have had to have been 4x and 4x. We're always going to put AC here. If it has an A, I'm sorry, AX, not AC, sorry, AX squared, so that's our AX squared right there. And then we're going to put our C over here. Now, if that was the box, could you tell what the two binomials would be? How you can do it is you can find the greatest common factor between these two. So what's the greatest common factor between those? It's 4. And between these two is x. Between these two is x. Between these two is 4. And so we have just found our two binomials that would get us this. We just worked backwards. So it would just be x plus 4 and x plus 4, because we use those. So that's how you use the box method backwards. You fill in the box and you figure out what the binomials would be by finding the greatest common factor. Okay, let's try this one. First step is always the greatest common factor. They're all even, so the greatest common factor is 2. If there is one, we must factor it out, because we don't want to find our C we don't want to find our C and B until we've factored that out. So if I find the greatest common factor, then I divide by it to find out what goes in here. So that's an x squared minus 8x plus 7. So now, what's C? It's 7. Remember, it's kind of like an A there, but A was 1. So you can kind of picture that. And then B was negative 8. So what factors of 7 add up to negative 8? Well, I love prime numbers, 7, because there's only one set of factors, 1 and 7. How do I get a negative 8, though? 1 plus 7 is 8, not negative 8. Well, that means they both must have been negative, because a negative 1 times a negative 7 is positive 7. So that works. So what do I do? Remember, I put the x. I put negative 1x and negative 7x. Then I put my, what do I put there? It's down here too, ax squared. I put my ax squared there, and then I put my, remember, I'm just using this piece, just the trinomial after the greatest common factor, and I'm going to put my c there. Keep in mind that that 2 that you factored out must go in your final answer. We're just ignoring it to find those two binomials because we already took that out. So, greatest common factor, that's a 1. There's nothing in common. Greatest common factor here is an x. Greatest common factor here is an x, and greatest common factor here is a 7. Now here's the tricky part. It's only when you have those two negative and that positive. We didn't pull any negatives out, right? But how could you get a 7, 1 times 7, but a 1 times an x doesn't get me a negative x? So that's when we should remember to pull out, that's like our double check. We want to pull out a negative so that a negative times a negative still gives me my positive, but when I multiply x times a negative 7, I get that negative 7x. So always check your box, especially when this one's positive and those two are negative. That's a little tricky. Okay, so what do we have? We have x minus 1, that's these guys, and x minus 7. That's these guys. Now, I don't know if any of you noticed, but did you see the negative 1 and the negative 7 and notice that that's an x minus 1 and x minus 7? Did you notice that? And over here it was 4 and 4, and then that was 4 and 4. Again, that only works when a is 1, but it's still a nice trick to know, because then let's try a shortcut, okay? So is there a greatest common factor? No, because that's an x and that's a number. So there's nothing greatest common factor. What is AC? That'd be negative 6. What is B? It's 5. Can you think of two numbers that multiply to negative 6 and add up to 5? Well, this 6 is kind of tricky, because if I want to add to get 5, that's either a negative 1 and a 6, or it's a negative 2 and a 3. Some people don't actually add. They just think, oh, 2 and 3, it's 5. All that is true. Positive 2 plus positive 3 is 5, but a negative 2 plus 3 is definitely not 5. It's 1. So this is actually our go-to. And if you remember that pattern from before, you might not have to use the box method. The box is there to use it, but let's not use it this time. If A is 1, and it is, then all we have to do is say, oh, that's negative 1 and 6. So we just put our factors down like that. You could always double check. What's x times x? X squared. And we get negative 1x and a positive 6x. That gets me that 5x back there. And then the negative 1 and the 6 gets me a negative 6. And that's exactly what we started with. So let's use the shortcut again on this one. Is there a greatest common factor? No. AC, what is AC? It is negative 12. What is B? It's negative 4. So we've got to find some factors of negative 12 that add up to negative 4. Now again, if you see it, beautiful. But if you don't, then you're going to go 1 times negative 12, 2 times negative 6, 3 times negative 4. And you'll see right there is my negative 4. What's my shortcut? I mean, you can put 2x, negative 6x, x squared, and negative 12, and factor it out, right? We can factor it out. Factor out the negative 6 there, the x there, and the x there. And we get, you see the 2 and the negative 6? That's what was up there too. So we just get x minus 6 and x plus 2. Does it matter which way you do this? No. You can do x plus 2 first or x minus 6 first. As long as you have both of them, you're going to get the right answer. And let's see. Shortcut or not. I started these for you. We've got the n squared and the 54. Is there a greatest common factor? Nope, no greatest common factor. So some people can just see it. Other people, they need to write it down. What are the factors of 54 that add up to 9? Well, there's 1 in 54. And some people kind of skip. They'll say, oh, well, 54, 5 plus 4 is 9. So what about 9? Yeah, 6 times 9. That works. What about 2? 2 goes into 20 to 50, 25 times. Wait, 2 goes into 5 2 times with 1 left over, and it goes into 12 6 times. That's not right. 2 goes into there with 1 left over. Oh, that's because I put a 52. It's like something's wrong there. 14, so that would have been a 7. And 3 goes into there. Let's see, 3 goes into 54, goes into 5, and then 18 times. 4 doesn't, 5 doesn't, 6 does, 7 doesn't, 8 does. Okay, that's it. So which ones add up to 9? Well, that adds up to 15. That adds up to 18, 19, 20. None of them, right? None of them add up to 9. Do you know what that means? That means it's prime. That happens every once in a while. It's okay. It's not going to happen a lot. But if you systematically do 1, 2, 3, 4, 5, 6 in your calculator and just find all the factors, and you don't find any factors of 54 that add up to 9, it's prime. It's okay. Remember, that is an option. Sometimes that happens. So I wanted to show you one of those. Now, then, factors of 45 that add up, negative 45, that add up to negative 4. So I'm going to do 1 and negative 45. 2 doesn't. 3 does. 4 doesn't. 5 does. 6, 7, 8, 9. 5 times 9, remember, is 45. So 3... Well, let's see. This one works, right, when we get a negative 9. So let's just go for that. We don't even care what. I put the 3 down because I knew it did. It's 15. But if you can see it, you don't have to write them all down. Okay, so we get x, remember, our shortcut, x plus 5, x minus 9. Can use the box, right? That would have been a 5x and a negative 9x, but you don't have to if you see it, right? Greatest common factor would, oh, sorry, I did that wrong. It said v and I did x. Yeah, so that would have been a v and a negative 9. All right, so that's a prime number. Can you see it? I can see it. X and x, because x times x has to get me my x squared. There's only 2 factors of 3 and 1. So now you have to figure out about your signs. How do you get a negative 4 when you add 3x and a 1x? Well, they both have to be negative. What is negative 3 times negative 1? Still positive 3? Yeah, it is. No greatest common factor there, but notice there's a greatest common factor here. It's a 5. So when I divide each of those by 5, put them in here, then this is the trinomial that I'll use. So I get x squared plus 6x minus 7. 2 factors of 7 that add up to 6. Well, 7's prime, so there's only 2 factors. And I need a positive 6. That means I needed a 7x and a negative x, because that gets me my 6x. So that means I have x minus 1, right? There's my x minus 1 and my x plus 7. That would have been these guys, right? Okay, so I showed you kind of the box method. I showed you a little shortcut. And next time, we'll do it when a is greater than 1. Good luck. M squared signing out.